Hi, in this video we will learn about basics of systems of linear equations. It will be mostly definitions and terminology about the system of linear equations. Let us start with what is a linear equation. Well, it is an equation involving, an equation, a linear equation in variables. So it will have some variables, x1, x2 up to xn is an equation that can be written in the form. So we have this variable x1, x2 up to xn. So the equation is linear if the variable x1 is multiplied by a number, variable x2 is multiplied by another number, and so on up to xn. Then these are added and then equals to a number, a constant, where a1, a2 up to an and b are constants. So something like, example, something like 2x plus y equals to 3 is a linear equation in x and y. However, something like x squared plus y equals to 3 is not. Why? Well, we cannot put any power there for variables. Just a number multiplied variable plus another number multiplied to another variable. Or something like x1 plus 2x2 up to 3x10 or 10x10 is equal to 20 is a linear equation with each coefficient, if each variable is multiplied by a coefficient constant. But something like x1 times x2 times x3 up to xn or x10 equals to 20 is not, because we cannot multiply two variables in the linear equations. Or simpler versions would be, this is not a linear equation. It is an equation in x and y, z, but it's not linear. The linear equation must be something of this form, for example. So just these linear equations are this specific. You can write them in this form. And well, we already actually know something about these guys. Remark, linear equations in x1 up to xn are equations for hyperplanes in Rn. So we studied these things already, and yeah, any of the equations for hyperplanes are equations, linear equations in those variables. Okay, so that's the linear. How about system of linear equations? Well, put bunch of these together. A set of a finite linear equations together is called a system of linear equations. So you put bunch of these together, and that we call it a system. So something like, example, something like x1 plus 3x2 equals to x3, or x2 minus x3 equals to x1. So put these together. This is a system of linear equations. Or x plus 2y equals to 1, and x minus y is equal to 2. That's another system of linear equation. Or linear equation, this can be more than 2. It can be any number of finite number of equation. For example, it can be x plus y equals to 1, y plus z is equal to 2, x minus 2z is equal to 3, and well, put all of them together. That's a system of linear equation. Just a fancy word for, well, put bunch of these linear equations together. There is a format that when we write these equations in, that would be very useful. It's called the standard form. Standard form for the SLEs, system of linear equations. Well, we say a system of linear equation is written in the standard form if it follows these two conditions. First of all, each equation is written in the standard form. So each equation is written in the standard form. What is the standard form? Well, standard form is the one we just wrote up there. So each one of these guys are of the form like a1 x1 plus a2 x2, all the terms with the variables one side and then the constant on the other side. But we want also them to have another arrangement, that in different equations, like variables are aligned. So like variables in different equations are aligned. In other words, if I have, well, x1, x2 up to xn, well, the first equation, the coefficient of x1 is a1, a2 is for that, a3, an is for xn, and then we have b. But just to make the different equation, I will just write 1, 1, 1, 2, 1, and b1. Then a 2, 1, x1 plus a 2, 2, x2 plus a 2n xn equals to b2. You see, x1s are aligned, x2s are aligned, and so on. So on, this continues up to a m1 x1 plus a m2 x2 up to a mn xn equals to bm. And that is what we mean by standard form. all the equations are written in the standard form. The like variables are aligned from different equations are aligned, and well, this is another thing, the equality and the constant ones are also aligned. So that's what we have there. And well, why do we write this in this form? Because this is what we can use and turn this equation into something called augmented matrix. Augmented matrix of SLE. SLE is short for systems of linear equations. Okay, so when you write the equation in this form, in the standard form, you can put all the coefficients, just ignore the numbers and sums and all these signs, just put the coefficients in an array. So 1 1 here, 1 2 here, 1 and there, and then a2 1, a2 2, a2n, and this goes amn, am1, am2 goes up to amn, and then you draw the separating line and then write the right hand side constants like this. This is called the augmented matrix of the above system of linear equations. So this is augmented. We will work with this augmented matrices instead of working with the SLEs themselves. Let us just do some examples. Find the augmented matrix of the given SLEs. So the first one is what I have here. Okay, yeah, I have x1 plus 2x2 equals to 3, and then x1 minus x2 is equal to 1. I have another one here. We have x1 plus 2x2 is equal to 1. x1 minus x2 plus x3 is equal to 0. And x2 plus 2x3 is equal to 2. And the last one, well, that can be like x1 plus x2, x3, x4, and x5 is equal to 5, and x1 minus x2 plus x4 minus x5 is equal to 2. So let's just write the augmented matrix. First thing to note that is that you have to make sure that the equation is written in the standard form. Here, each equation is written in the standard form, and the like variables are aligned, equality is aligned. Then right away, you just put the coefficient of x1 for the first equation, x2 for the first equation, separating line, the constant term. 1, -1, 1. For this equation, for this system of linear equation, you notice right away that this is not written in the standard form. So you have to be very careful. First, write it in the standard form. So I will write x1 plus 2x2. Put some space for x3 and then equal to 1. then x1 minus x2. I'm aligning the different variables from different equations on the same column, and then the third equation doesn't have any x1, so we won't write that. 2x, it starts with x2 plus 2x3 is equal to 2. Now that it is written in the standard form, we can have the augmented matrix. 1, 2, there is no x3, it means that the coefficient is 0, 1, and 1, negative 1, 1, 0, and 0, 1, 2, 2. The last one. Okay, so this equation, this system of linear equations have 5 variables, 5 unknowns, and 2 equations, and they are, well, written in the standard form. You see these are aligned and equality, so just right away go ahead and just write the coefficients. That's what we have. 1, negative 1, 0, 1, negative 1, 2. That is the augmented matrix. So you have to now know what is a system of linear equation, what kind of equations are called linear, and how to find augmented matrix of a system of linear equation.